Well, good morning. This is Pearson Publishing, a student companion, and on 10.6 circles and arcs. And so, we'll go through this. It's a good instructional guide. Is a circle a two-dimensional figure? Yeah. Let's see. Is a circle a polygon? No, it doesn't have multiple sides. Okay. And is every point in a circle same distance from the center? Well, let's skip that one and go to number 4. Circle the figure that is a circle. That's a circle. This is not, this is not, this is not, because a circle is defined by finding a central point. In this case, we'll call it A, capital letter, and then you draw a radius, and then all points that are equidistant from the center is the definition of a circle. So yes, number 3, is every point the circle same distance from the center? Absolutely. Okay. An arc is part of a circle. So going from here to here, see it's in this image here, A to C, that's a minor arc. So a minor arc, whoops, minor arc shown is AC. And you label it as the two endpoints, capital letters, and a little curvy thingy across the top to show the curvy arc. Now there's another minor arc here. You got you got BC. Okay. Semicircles mean half a circle. Half. So look, you've got AB here, or AB going this way. So a semicircle, here we'll cover up the word half. Look, this part of AB, and the designation is going to be the same designation for the arc notation. Okay. Okay, all these I broke them up into little pieces so I could focus upon them. A minor arc. Well, they show a minor arc, LK, and it is smaller than a semicircle. There's also the minor arc JL, um, which I'm going to show there, JL. Okay, a major arc. The major arc goes the longer way around. So here, look, we always assume when you see the letters LK by itself, you assume the shortest path. So it's a minor arc. But if you want the endpoints to be LK and you want to go the long way around, well, then you need a third point to sort of force you to go along the way. So that notation is going to be same endpoints L and K, but you got to have a J in the middle to sort of force you to go this way. So major arc is obviously larger than a semicircle. There you go. Okay. Let's see. You need 3 points, as I just discussed, to create a major arc. So it's going to be endpoint, endpoint, and this middle point to force you to go the long way. Need 2 points for a minor arc. So LK this way. Okay. Let's see what we got now. Circle the name of KL. Well, it's a minor arc. Okay. Circle name. First of 3 letters, it's a major arc. Okay. Name in the arcs. I dislike doing these drawing lines to things, but let's work with it. Now, the big important thing to discuss is they're talking about arcs now, and we're talking about angles. And we need to understand at this point in the conversation, an arc is measured by the central angle. Let me write that. Arc. And we're going to use the word central angle. So PAQ. PAQ. We're talking about this angle right here. And this is the center A. This is, as I said before, circle A. PAQ, that central angle, the measure of angle PAQ is equal to the measure of the arc PQ. They are synonymous. Central angle, arc, yes, in terms of measurement. So Okay, on that idea, let's find uh, PAQ. We need to find PQ. This. There we go. There's the matchup. Okay, let me erase what I wrote and then do the next matchup. Let's see. We have QAR. QAR. So that's the central angle. So QR is the arc. QR. Whoa, I really wanted that to. Oh, well, we'll pick a different color later. Okay. RAS. Uh, RAS. Okay, so RS is the deal. Wait, yeah. Oh, there it is. Okay, we're good. And then SAP. SAP. Okay, so the central angle is SAP, the SP is the arc. So um, there we go. And what's left? SAQ. SAQ. Well, SQ is the deal. Oh, well, that's easy. Okay. The minor arcs in this picture, let's see. Minor arcs. Well, you got RS, you got SP, you got PQ. Let's just quick write those out. RS, uh, SP or PS, PQ, uh, QS is a minor arc, right? And what's left? What did I miss? Let's try this again. Let's see. RS, PS, PQ. I didn't put RQ. Okay. Okay. Let's see what we got next. Let's see. The measure of an arc is equal to the measure of its corresponding central angle. Yes, I already described that. So the measure of a major arc is measure of the related angle subtracted from 360, right? Because it forces because you're going a long way around. Okay. And the measure of a semicircle obviously is half of a circle, 180. Okay, let's go around here. So let's see. The measure of RT is shown. The central angle is 50 degrees. So that means this measurement here, the measure of RT is 50 degrees, but so is the central angle RST. We're good. Okay, here, the measure of the angle T, the arc really, the major arc TQR is going to be this longer, whoops, I should put that in blue, is going to be the longer way around here. Well, that's going to be 360 minus the 50, right? So then you get 310 degrees. We're good? I think so. So, okay. And let's take a look. Oh, well, obviously you can add arcs together. So if you know that, let's see, AB, if you're told that this is 40 degrees for the measure of this arc, and BC is 100, well, then obviously ABC or AC is 140 degrees. Okay, let's take a look at the next part. Let's go down here for 20. I'll write in red for that. If AB is X and BC is Y, well then clearly the measure of this arc ABC is going to be X plus Y. Okay. Let's see. Let's find all the measures of all this stuff. Let's see. PCR was 77 degrees in that image, right? The central angle is 77 degrees. I just want to make sure we got this together. Right, right. This is what I was about to say. PR is the same measure as the central angle. Perfect. Okay. And let's go over here. Okay. CS is equal to PC. I need to color code this. PCS, PCS, going all the way from here to here is this. Well, that's 180 degrees. Okay, so now I understand it's a semicircle. Minus PCR, PCR minus that is going to give you this remaining piece over here, the RCS. Okay, so let's fill everything in there. So it's going to be this semicircle minus this minor arc leaves you 103 degrees. So that means this over here is 103 degrees. So RCS equals 103, right? RS is obviously equal to the central angle, so that's 103 degrees as well. Okay, let's erase all this. Okay. Let's see. PRQ going all the way around this way. That's what we're talking about here for this. So that's equal to PR added to RS added to SQ. That looks legitimate. Okay, so let's fill in what values we know. PR is obviously 77 degrees, central angles there. QS is going to be 28 degrees. And RS, we just found out a moment ago, was 103. Right? And so that means you add that all together, it's 208 degrees. So it's 208 degrees all the way from here all the way to here. Okay. PQR going around this way. Tell you what, let me see if I can grab this. I can't grab that image separately, can I? No, I wanted to not erase this. Oh well. Down here, P from here, PQR going all the way around this way is pretty straightforward. It's going to be 360 degrees minus the 77. So you get 283 degrees. Okay. Next one. Let's see. The circumference of a circle is, 2 pi r or pi d. Okay, explain why you could use either of these two to find the circumference of a circle, because either of those are the formula for it. This part here, the d, that is 2r. Okay, that's so much for that explanation. Finding distance. Okay. Car has a circular turning radius of, okay, 16.1 feet. The distance between the two front tires is 4.7 feet. How much further does the tire on the outside travel than the inside? Okay. The two circles do have the same center. To find the radius of the inner circle, do you add or subtract? You're going to have to subtract 4.7 from the 6.1. So going from here to here, that answer, oh, here, they got it here. The radius of the outer circle is 16.1. And so you take 16.1 minus this difference, and it's going to give you 11.4. So this distance here is 11.4. Nice handwriting. From here to here. Okay. Circumference of the outer circle is 2 pi r. So it's 2 pi, and the radius of the outer circle is 16.1. So when you multiply 2 pi times 16.1, you get 32.2 pi for the outer circle, for this circumference going all the way from around. And the inner circle, well, that's going to be the new radius that we just figured out. So that's 11.4 times the 2 pi. So that's going to give you 22.8 pi for that circumference going around there. Okay. Find the differences between the two. Well, we put our values in there. So That's going to be 32.2 pi minus 22.8 pi, which is going to give us 9.4 pi. And if you put in 3.14, you'll approximate, then you're going to get 29.516 feet. Okay, so the tire on the outside travels about 30 feet further, which is why cars have a differential built in, transmission there, or the rear end. So this way you can deal with that, the difference of wheels turning from left to right on the car. Okay, this part is a different concept. Instead of talking about degree measure, we're going to talk about length. But degrees apply to this. Think about it this way. I just want to sort of give you a little illustration here. If you draw a circle and we talk about an arc, so from here to here, remember the circumference of a circle is 2 pi r. So that would give us a measurement of going all the way around the circle. But if you're just focused on this part of it, then what you need to do is recognize that whatever these degrees are, whatever that is, it's a proportion. This is going to be what they're showing right here, A, B. The measure, if you want to know the length of this arc, then whatever this degree is, whatever that is here, if that is placed in the top of this fraction, so it's this many degrees out of a total of 360, will give you the proportion of that of the circumference that makes up that arc. So then this part here is the circumference. So that proportion times the total will give you the actual length of AB. Okay, so then yes, the length of the arc is a fraction of circumference of the circle, no doubt. Okay, and in circle O, the measure of the arc in degrees of AB is equal to the measure of the central angle, AOB. That is absolutely true. Let's take a look at this over here. Instead of looking at what's wrong, let's start off with what's right. The length of AB, and then we'll compare, of arc AB is going to be equal to the measure of the degrees of AB over 360 times the circumference of a circle. Okay, but it's going to be 2 pi and the radius. Well, this is showing a diameter of 4 meters. So the radius is 2 meters. So that's what goes here. See, there's the mistake. Okay. All right, so let's run down the list. Is AC a semicircle? Absolutely. Does AB, the measure, equal 180 minus 70 is 110? Absolutely. Is the radius 4? No. It's 2 meters. So what's the error? Yeah, the person put a diameter instead of a radius. Okay, let's find the length anyway. Let me move this down a little bit. So the length of AB is equal to the measure of that arc in degrees over 360 degrees times 2 pi and 2 meters. So let me grab my calculator. So you're going to have 70 divided by 360 gives you that. What the heck? I'll try again. 70 divided by 360. And then times that by 2 and 2. There you go. You get 0.7 repeating pi meters. So let's times that by pi. So there you go, 2.4 roughly. And that's it. Thanks for watching.